So, glucose is a biological fuel used by cells to satisfy the energy needs of plants and animals. The overall reaction for the metabolism of glucose is represented by the unbalanced equation. The balanced equation and the enthalpy change for the cellular respiration of glucose can be represented as. So, if we balance this here, now, in terms of the enthalpy change, when we're not given any kind of calorimetry data or reference equations, remember that you can always find the enthalpy change of reaction by using the formation summation equation, which is your enthalpy change of the products minus the sum of your enthalpy change of the reactants. And we can find that in our data booklet for all the enthalpy of formation values. So going to the standard molar enthalpies of formation, I'm going to go and find glucose. Here is that one value. Then I'm going to go and find carbon dioxide, which is the other value. Here, negative 393.5. Then I'm going to go to water, which is over here, water liquid. And then oxygen is not here because remember, all single elements have an enthalpy of formation of 0 since they're not actually making compounds. So now we're going to plug in all the values into the equation here. And this leaves us with an enthalpy change of negative 2,802.7. Since it's negative, we know that it is exothermic. So that would mean that the enthalpy value should be on the products side to show that heat is released. And so the answer here that shows the right enthalpy change value along with the right placement of that enthalpy change value in the product side and the balanced reaction is option C. Now for the next question here, it says if a solid glucose is completely burned, and that's the key word here. I'm going to underline that actually in a different color. Burned in the flame of a Bunsen burner, the enthalpy change is. Now, when it's burned, that means that it's a combustion reaction. And unless it's otherwise indicated that this is done in a closed system, combustion reactions always produce water vapor as opposed to liquid form of water over here. So if we recalculate that, this small change here causes our enthalpy change of reaction to decrease by a significant amount. So about negative 2,538.5 kilojoules is the final. So then the most appropriate answer here is that the enthalpy change is going to be less than it is during cellular respiration because your H2O gas releases less, right? If we look here, it releases negative 241.8, whereas water liquid releases negative 285.8 instead. So the most appropriate answer would be B over here. So for this diploma question here, we have our decomposition of nitroglycerin over here. And so it's an explosive compound that when absorbed by support material becomes safer to handle and transport. Nitroglycerin can undergo an explosive decomposition as represented by this equation here. So in the decomposition equation, the product species that would have an enthalpy of formation of 0 are, okay, so the things that have an enthalpy formation of 0 are elements because they are not forming compounds, right? Enthalpy of formation is specifically the energy that's involved when two elements combine to form a compound. So that would be namely the hydrogen over here and the oxygen. So it would be nitrogen and oxygen, and that would be option D. Now here we're given a table full of standard enthalpies of formation of unknown elements, but the elements don't matter. X, Y, Z represents the elements. And then we're given an enthalpy change of reaction here. So here it asks for the standard molar enthalpy of formation of W. And if we notice here, that's the only one that's not given. Now I want to make something clear here. If it asked for the molar enthalpy of reaction, then that's a very straightforward question, because all you have to do is that enthalpy change value. You just have to take that enthalpy change value, which I would say, if I'm writing it like this, Rxn for enthalpy change of reaction, that enthalpy change value divided by the coefficient, which would represent the moles in the chemical equation, that would give us the molar enthalpy of reaction. And so in this case, for W, that would be minus 562.0 kilojoules divided by 2. And so the delta H Rxn here for this equation would be minus 281 kilojoules per mole. But it's asking for formation. So whenever you see that word formation, that means you need to use the delta H is equal to the summation, okay, of the products minus the reactants, and you're going to isolate for it inside here. And then that gives us the molar enthalpy of formation for W of about 120 kilojoules per mole. So thermal stability refers to the ability of a compound to resist heat or state change as heat or energy is applied to it. You can also think about it as a compound's ability to resist decomposing, specifically when heat is being applied to it. And that's a lot of thermal energy. The general rule here is that the greater the negative value for the enthalpy of formation is, then the more thermally stable that compound is. So let's say we're asked to rank the following compounds from most thermally stable to least thermally stable. All we have to do is look at their molar enthalpy of formation values and then order them according to the rule stated right here. So if I look at, let's say, ethane, that has a molar enthalpy of formation of negative 84.0 kilojoules per mole. If I find methanol, that has a molar enthalpy of formation of negative 239.2 kilojoules per mole. And then finally, if I look at magnesium chloride, now typically the ionic compounds are going to be the most thermally stable because they release the most energy when they're being formed. Right, ionic bonds are much stronger than covalent bonds, so you can expect that it's going to be harder to break them apart. Nevertheless, this is going to have a molar enthalpy of formation of negative 641.3 kilojoules per mole. So if we're looking from the most thermally stable to least, well, the more negative you are, the more thermally stable you are. So with that being said, then the most thermally stable would be magnesium chloride, or MgCl2. Then after that is going to be methanol, CH3OH, because it's negative 239.2. And then the least thermally stable is going to be ethane, C2H6. And so the greater the negative, the more thermally stable that compound is going to be. So for here, when we're looking at the processes of cracking and oil refining and production, one of the byproducts of a cracking process used at Novacor is ethine. Okay, so in the presence of a palladium catalyst, that's a key word here, the ethine forms ethene and ethane. This reaction is represented by the unbalanced reaction here. But I do want to point out that it is an exothermic reaction since the energy is released and written on the product side. The energy that represents both the catalyzed and the uncatalyzed reaction is, so remember, catalysts do a couple of things. Okay, they speed up the rate of reaction without getting consumed, nor do they change the enthalpy change, right? So they're not actually changing the reaction. What they do is they lower the activation energy. And so if I'm looking at a graph, first, if I know that this is exothermic, I know it's got to be A or C. So the activation energy is this section here. The very top is what we would call the activated complex, right? Where your system, everything essentially accumulates momentarily and your system has the highest amount of potential energy. And so from wherever your reaction starts off at to the activated complex, this energy here, that difference in potential energy, that's your activation energy. And so what catalysts do is they lower that so that the reaction goes faster. Now, it can't be this because remember that activation or catalysts do not change the enthalpy value here. And that would change the enthalpy since it's the difference between the reactants and the products over here. And if it ended up there, that changes the enthalpy. So over here, enthalpy remains the same, but that activation energy as represented by that dotted line over here is lower. So the best answer here would be C.